This is the product rule of differentiation, and the product rule says that if you've got two functions, u which depends on x and v which depends on x, and if y is the product of the two functions, well then dy dx is given by the rule u dv dx plus v times du dx. And our starting point for this proof, as with all first principles proofs, is our definition of what dy dx is. So just to recap on that, dy dx is the limit as h tends towards 0 of fx plus h minus fx over h. And we label the parts on this because the parts of the proof give us our steps. So 1, part 2 is to get fx plus h, part 3 is to subtract our two answers, part 4 is to divide by h, and step 5 then is to get the limit of our answer. So starting with step 1, fx, well fx stands for the function, f stands for the function we're talking about, which is y in this case. Fx is equal, so we'll label this as step 1, is equal to ux by vx. Step 2, from our formula, is to get fx plus h, and this involves substituting in x plus h everywhere we see x. So it's ux plus h multiplied by the v x plus h. Step 3 is to subtract our two answers, fx plus h minus fx equals u x plus h dot v of x plus h minus ux vx. Now the trouble with step 3 in this proof is it leads us up a cul-de-sac. We can't really go any further with it as it stands at the moment. So we have to be a bit inventive with our algebra, and we bring in some new terms which will help us to progress. And this next step is really a step you have to learn. It would be hard to think of it if you hadn't seen it before. So let's just emphasize this. And the way to go about this is just to rewrite what we have at the moment. Vx plus h, and I'm going to leave a big gap, and at the end of the gap I'm just going to put my minus u x vx. Now the reason for the gap is we're going to add in two new terms, and again you're probably better off just to practice this a few times and get to know those terms. So the first one is we're going to subtract u x plus h vx, and to compensate, of course, we're going to have to add that term again. So I might just make some space for myself here, and if we just move this back further. So we're going to add the same term again, which is u x plus h vx, and of course we still have to put back in the minus ux vx, which was there originally. Okay, so that's the step, and this allows us to progress now, because we can now factorize, and we can write it as take out what's common in these first two terms. So we put this and this, u of x plus h comes out, into what's left, vx plus h minus vx, and we can do the same with the next two terms, plus if we take out what's common here, which is Vx. So Vx into Ux plus H minus Ux. And step 4 is to divide our answer by h, and step 5 is to get the limit of that answer. So as this is a long expression, we might just save time by doing step 4 and 5 together. So step 4 and 5. We're going to get the limit and divide both sides and divide by h at the same time. So we'll get the limit as h goes toward 0 of fx plus h minus fx over h. So that's the left hand side taken care of, equals. Let's get the limit of the right hand side, so we can divide that in two parts. We'll do the u parts first, and then we'll do this first term here, which is ux plus h. So the limit as h goes towards 0 of ux plus h into v of x plus h minus vx. We'll put the h over this here, or sorry, put the h under the v part. A lot of students get confused as to why you don't put the h under the u as well, but that stems from a misunderstanding of division of basic numbers. I mean, if you have the number like, for example, 3 by 5 and divide your answer by 3, you don't divide both numbers by 3, you just divide one of them, and it's the same here. So if you're confused by this, just think back to numbers, and you should understand it more clearly then. And now the next bit is plus the limit as h goes towards 0 of vx by ux plus h minus ux all over h. And we're very nearly there now, because if we inspect each of these parts of the formula here, well, this is the definition of dy dx. So the left hand side is dy dx. Here, if h goes to 0, we're left with u, and that can then go outside the limit, and it becomes the limit of vx plus h minus vx over h, which is simply the definition of dv dx. And similarly here we have v du dx. So we have just proved that if that dy dx is equal, so this becomes dy dx. So again, take out the u term here, that comes outside, and you get u dv dx plus, if you take out the v here outside the limit, you get v times du dx. And that's it proved.